right? So the first question in part 1 says state true or false in the following questions. Okay, so we want to state whether whether what we have is true or false for the following statements. Okay, state true or false for the following. All right, and what are the statements that we have? Okay, so we're going to look at them quickly. Excuse me. Okay, so let's go on. So the first one here says that you are giving, let me call it A, you are giving R intersection Z, and the Z is equal to N. Okay, and so you have a space to say whether this statement is true or false. The second one is that you're giving Z union Q, and then you have union Q prime and is equal to Z, and we are to state whether that is true or false. So here now we have N union, here we have Z intersection Q, and then you have union R, okay, and the bracket was closed, and you have intersection Q is equal to an empty set. We are also to state whether that is true or false. And then there is the last one here, R intersection N is equal to Z. So you are also to state whether that is true. And I would like to put a fifth. Okay, so let's take it that you have something like R union say Q prime intersection N, you know, is equal to the empty set. Is this one true or false? Okay, so quickly let's look at that. So when where is this all these questions, where are they coming from? So this is from the topic number system. Okay, so you remember the first topic you treat when it comes to Maths 101 is number systems. There you learn about the 6 major types of numbers, where you can add the 7th, and that is your prime numbers. Okay, then you have your natural numbers, you have your integers, you have your rational numbers, irrational numbers, your R, which is real numbers, and your C, which is the complex numbers. Okay, so, and one of the things we saw is a relationship between these numbers, these types of numbers, and it is those relationships that actually will help you answer questions like this. Please be very mindful when it comes to our exams. These kind of questions, you will see many of them. Okay, and what is the relationship? We saw that P is under N. So all prime numbers are actually positive whole numbers. What is N? N are positive whole numbers, which you also call counting numbers. And we saw that all positive whole numbers are under Z. And what is Z? Z are your integers, which are whole numbers, both positive and negative, including 0. And then we also saw that all integers are inside Q, where your Q are rational numbers, which means numbers that can be expressed as fractions of integers, where your denominator must not be 0. Okay, so we saw that any whole number, for instance 5, can actually be written as a fraction of integers, say 5 over 1. And if I have something like, say, minus 12, I can actually write minus 12 as minus 12 over 1. So any integer can be written in a fractional form where the denominator is 1. Therefore, all of them are actually inside your rational numbers. Okay, and then when it comes to these two, there is no containment. You know, we call this, under set theory, we call it containment. That's subset. So q and q prime does not have any containment relationship. And what is their relationship? Their relationship is that if you join the two of them together, you are going to get the set of your real numbers. In fact, they are equal to your real numbers. So meanwhile, what are irrational numbers? Remember that rational numbers are numbers that can be written as fractions of integers. What that means is that irrational numbers cannot be written as fractions of integers. And another way to identify them is that when they are in decimal form, irrational numbers, they neither terminate nor recur, but rational numbers can terminate, and if they don't terminate, then they will recur. For instance, if I have something like 1 over 2, this is a rational number because 1 over 2 will just give you in decimal 0.5. It terminates immediately. Then again, 1 over 3 is also a rational number because in decimal form, even though it does not terminate, but it will keep repeating a particular digit after the decimal point. So you call such decimal numbers recurring decimals. So when you have a decimal number that either terminates or recur, you refer to such decimal numbers as rational numbers. But then when you have some examples where they don't terminate and they don't recur, then those ones are called irrational numbers. Example is your pi. Okay, for instance, if you check your pi with a calculator, it's going to give you something like 3.141, and then it continues bringing different digits, and it continues to infinity. It does not terminate and it does not repeat any particular digit in any order. So now the implication is that any number that is rational cannot be irrational at the same time. That's why sometimes when you discuss, you and your friend is trying to go out of point, you say, "Oga, can you be rational?" All right, so that means the person at that point is being irrational. Okay, so now the relationship, there are two relationships you can see between rational and irrational numbers, and that is one, their union is equal to your r. Okay, please take note of that. And then secondly, their intersection is always equal to empty, because they don't have anything in common. No number is rational and at the same time irrational, so their intersection is always empty. Okay, so that means the only relationship between this is that their union is equal to r. But then remember, we are still talking about containment. The two of them are inside r, so q is in r and q prime is also in r. And finally, r is inside c. Your c are complex numbers. That's numbers that contain the complex identity I. Okay, so those numbers, you get them when you take the square root of negative numbers. Okay, so now this relationship is the most important thing that you need to be able to answer these questions. So let me write it here. P, which is prime numbers, are inside n. N are inside z. Z is inside q. Q together with q prime is inside r, and r is inside c. Okay, now please take note that if q intersection q prime is empty, the meaning is that if you take any other set that is below q, if you take its intersection with q prime, it will also be empty. Because, for instance, let's take it that you're talking about the Faculty of Physical Science, and you're saying that the intersection between the Faculty of Physical Science and Faculty of Management Science is empty, meaning that there is no student in physical science that will at the same time be in management science. That is true. So you do not also need to check the intersection between a department under physical science and the management science. For instance, the intersection between mathematics department and Faculty of Management Science will still be empty, because mathematics is already under physical science, so it's actually under a bigger set which is empty under intersection with the Faculty of Physical Science, of Management Science. So please take note of that if you take the intersection of, say, n with q, it will still be empty, because they are with q prime, it will still be empty because their oga kpatakpata, which is q, is already empty with q prime. The same thing will happen with z. Z intersection q prime will also be empty. The same thing will happen with p. P intersection q prime will also be empty. So because these three are under q, so since q is empty under intersection with q prime, the three of them will also be empty. So let's not waste time there. Let's go on now to answer our question now. So this is the first relationship that you need to be able to answer that question. And what's the second one? The second one is this general statement, which is actually found under set theory. And what is it? It says that if any set, let's say A, is a subset of another set, let's say B, that means A is inside B, then if you take their intersection, their intersection will always give you the smaller one. Don't bother checking their elements. Once you're told that A is inside B, their intersection will always be A, and their union will always be the bigger one. So their intersection is always the smaller one, their union is always the bigger one. Okay, so take note of that, and that's exactly what we are going to use in answering these questions. These questions are actually very simple. Okay, so there are questions that I say you look and answer. You don't even need to write anything. Okay, so let's come back here now. So R intersection Z is equal to N. Is it true? And the answer is no, it's false. There is no N here self. So R intersection Z, what I should be asking is between R and Z, which one is smaller or which one is contained in the other. So this answer is false. So the question is, what is it supposed to be? It's actually supposed to be what? Z, because Z is inside R. In fact, Z is inside Q and Q is inside R. So it's actually smaller than R. So this answer is false. This particular statement has no relationship with N at all. Okay, so we go to the second one. Permit me, okay, maybe I should bring that second one down. All right. Okay, so the second one, let me bring it down here. That's B. So for B, we are told that Z union Q prime is equal to Z. So let's see if that is true. So we are checking if this is true. So let's see. First of all, you know board mass and brackets. So Z and Q, which one is bigger? From our relationship, Q is bigger than Z. So their union will be Q. Then you now have union Q prime. So finally, Q prime union Q, remember I said it is equal to R. Okay, so that means this one, number 2, is also false. So you have false here. And then we go to the third one. Let's try to bring it down here to see what that will give us. So there we are given N, which is natural numbers union Z, and then intersection Q, and then union R. Okay, you close the bracket, then intersection Q again. Okay, so remember, I will always tell students that the length of a question doesn't make any difference. This same question, you don't even need to also write anything and you get your answer. So we start from the innermost bracket. So that means I'm going to bring down N, then union. So this innermost bracket, Z intersection Q. What is my Z? My Z is smaller than my Q. So the intersection will be Z. Then I'll bring down union R. Remember to close this bracket, then intersection Q here. Okay, so what are you going to have? All right, so this is going to give us, okay, okay, it's all right, no problem. So let's move on. So here we'll see more examples. That's why I gave the fifth one. Okay, so here we are going to have, now when it is union or true or intersection or true, you can start with any two. So I can actually start with this first two and then do the last one, and I'll get the same answer with the person that will start with this first and then come back, because you can't do the three at a time. So let's assume I start with the first two. N union Z will be Z because Z is bigger than N. Then finally union R, then into intersection Q. So now what is Z union R? R is bigger than Z, so it will be R, then intersection Q. Finally, Q is smaller than R. Once you see intersection, you are looking for the smaller one, and once you see union, you are looking for the bigger one. And so this is going to be equal to Q, okay? And the question said that is equal to Q, right? Oh, sorry, it said that it is empty, okay? So that means it is not true. So this is also false. Okay, so we come here and we have false. So we can see that A, B to C are all false. So we can actually do this one here. Now, R intersection N is equal to Z. This is another false. There is no relationship between this and Z. Intersection of these two should actually give us N because N is smaller than R. Okay? I think there's a repetition there in A and D. Okay, so that means this is also false. Okay, and finally the fifth one. Okay, the fifth one here says, what is this going to give you? Remember what I said, that there is no relationship between N and Q. So their intersection will be empty. And then when you take the union of R and empty, R is bigger than empty. Empty is already empty. There is nothing there. So this should give you R and not empty. So this is also false. So the 5 questions there are all false. None of them is true. So but the essence of this is to help you understand how to simplify questions on this particular topic, number system. All right. So and that is that for question 1. Okay, so we move over to question 2. So for question 2 there, you are given a rectangle, okay, and you are, okay, sorry, a set. Of course, the rectangle shows the universal set. So inside you have, let me use my this thing. Oh, this is going to waste my time. Okay, let me use my freehand sketching. Okay, so inside here, this is your A and this is your B, all right? And you are asked to represent each of the following expressions by shading the appropriate region. Okay, so you are to get the region that will represent A symmetric difference B. This symbol here means symmetric difference. And so what is A symmetric difference B? By definition, there are 2 ways you can actually define this. One of it is A union B minus here means normal difference minus A intersection B. Okay, so and this is a very beautiful way to help us do the shading. So what is A union B? Let's shade A union B. Everything here is your A union B. So we have shaded everything. And what is minus? Minus means excluding their intersection. And we can quickly use our eraser to remove their intersection. The intersection is the junction between the 2 of them. So what I'm removing now is the intersection of A union B. The intersection of A and B, sorry. Okay, so I'm removing their intersection. So what you have left now is your A symmetric difference B. And you are done, nothing more. So this is what you're asked to get. Okay, so we go to the next one, which is exercise B. So there you are asked to get okay, let's first of all get our set. So here again you have 2 sets, 2 subsets, and there are also A and B, and you are asked to get A complement then union B. Okay, so what is A complement union B? First of all, your A complement is the whole of the diagram, including the rectangle, except A. So I'm going to shade everything except A. Alright, something like this. And then they said union B. Remember that this particular intersection is part of B, but is also part of A. So that's why I didn't touch it when I talked about the complement. So then when it now comes to union, union means the sum of that complement and your B. And what is your B? Your B is the whole of this B circle. So that means you just have to add the remaining part, because this other part is already included in the A complement. So the remaining part from the intersection will be part of what you are required to shade. So that means this is a required portion. I hope this is making sense. Okay? Alright. So we move over to the third one. Okay, let me see if I can do that one by the side. Okay, let me go ahead here. Okay, so the third one, we are giving our set Venn diagram. Of course, you know this is from Venn diagram, and yet again you have two subsets of a universal set, and you are to find C complement. I think with what I said in your B here, it should be easy to find your C complement. So your C complement is going to be the whole shape apart from A. Sorry, A complement, not C complement. So the whole shape, I'm going to shade everything apart from A. So that means something like this is my C complement. Okay, so even from your question B, you should have seen what your C, the answer is going to be. So it's not going to touch this inner part because that part is also in A. And that's the solution for that one. Okay, so we move over to exercise 3. So exercise 3, we are told that you are given some sets. A is a set 2, 3, 4, 5, 6, and 7. And then remember, this is called the tabular form of set. You have the set builder notation. And then set B is 2, 4, 7, and 8. And then another set C is only 2, 4. Okay? And then they said fill in the blank spaces with subset or not a subset. Okay, so what are the questions? Here you are given B, and then there's a blank space, and there is A. Then question B or II, you are given C, then there's a blank space, there is A. And then finally question C, you are given empty set, and there is a blank space, and there is B. Okay, so you are to fill in the blank spaces with either a subset or not a proper subset. Okay, you know this is what we call, this one is just a subset, while this one is a proper subset. A proper subset means it contains all the elements inside the other one and some elements that are not there. So that's the meaning of proper subset. Okay, so a proper subset, that's proper subset. This one now is improper subset, sorry. So that means it can be equal, the two sets can be equal. So that's what we call this improper subset. Okay, so let's go on. So what do we do? A and B are what is going to be here. Of course, your A is a proper subset because, okay, no, it's not even a subset at all. 8 is in B, but not in C. Okay, so B is not a subset. It's not a proper subset of A. In fact, it's not even a subset at all, not to talk of an improper subset. Okay, so what about the second one, C and A? What's their relationship? 2 and 4 are inside your A. That means C is a proper subset of A. Alright? And then the last one, you don't even need to check the set to answer this last one. Your empty set is always a subset of all sets. And in fact, since your B contains some elements, therefore your empty set is a proper subset of your B. Right? So we move over, and that's the end of the first 3 questions. So we move over to the fourth one. All right, for the fourth, we are told that in a Canadian school, okay, let me use let me say in a Nigerian school, but here it says in a Canadian school. All right, so in a Nigerian school, 30 students offer music. I may not be able to finish the writing of this because of the time. Okay, so 30 students offer music, 40 offer history, what again? While 20 offer neither music or history. Is it neither or neither or neither nor? So it should be no, neither music nor history. Okay, or goes with either and no goes with neither. Okay, so it says how many students offer history. Let me use H for history, but not music. Let me use M for music. Okay, if there are 80 students, in the school. Okay, so this is the question that we are expected to answer. All right, so here there is a school that contains a total of 80 students. Okay, so that means your universal set is the cardinality of your universal set is 80. Anyway, they gave us some hints to the question, so but we can actually find them here. So let's see. So the cardinality of the universal set is 80. That's the total number of students in the school. All right, comma. And then they said the number of students that offer music. So the number of students that do music is 30. And the number of students that do history, N of history, that's cardinality of history, is 20. Okay, sorry, 40. Okay, and then they said 20 of them offer neither history or music. That means if you take the union of history and music, there are the complement of that union. That's people outside these two. They don't do these two at all. So that's the complement is equal to 20. All right, and they're asking us to find the number of students that offer history but not music. So let's try to represent this in a Venn diagram. That is going to help us a lot. Right? So what's the Venn diagram going to be? You have, this is music, and then this is history. Okay, so first of all you start from the intersection. All right, so you start from the intersection. So let the intersection be x. Okay, so that means the people here will be the number of people offering music minus this, which is equal to 30 minus x. And then the people here will be the number of people offering history without the intersection, which will be 40 minus x. Okay, so and then outside the two circles, which is their complement, is equal to 20. while the whole box is equal to 80. So what does that mean? First of all, let's interpret here, and so that you know what we are looking for. They said people offering history but not music. Where are those people? The people offering music without, is it history without music? Yeah, people offering history without music are the people here. All right, there are those people in this place I just shaded, which is actually 40 minus x. Okay, so in other words, what we are going to be doing is to get the value of our x, and to get our x, all we need to do is to sum everything there, which is 30 minus x, then plus x, plus 40 minus x, then plus the complement, which is 20. Everything should be equal to 80. Okay, so from here you will get, of course, this will cancel out this, so this is going to be 30 plus 40, which is 70, plus 20, which is 90. So you have 90 minus x is equal to 80. So if I take my 80 to this side and take my minus x to this side, I will get 90 minus 80, which is 10, and that is equal to x. Therefore, my M intersection H is equal to 10 students. Okay, so there are 10 students that offer both music and history. Therefore, what I am looking for, which is the number of students that offer history but not music, is going to be 40 minus x. And of course you can put, therefore, the number of students offering history but not music is equal to 40 minus x, which is equal to 40 minus 10, and that is 30. Okay, so 30 is the value of what we are looking for. But then, of course, in being able to fill up what we are given, note that you can actually write this question in this form. I can use another approach, and what is that? That if you take the number of the union of the two sets, it is equal to the number of the sum of the individual sets minus their intersection. Okay, so this is actually correct. Okay, so is equal to the number of the union of the union of the two sets is equal to the sum of the individual sets. That's joining these two circles and then removing their intersection. And why is it so? Okay, so because if you join the two sets, that means you would have joined the intersection 2 times, and the union cannot contain the intersection 2 times, so you just remove one of the intersection. That's where this formula is coming from. Okay, so this will help you, fill whatever you needed to, and then from there you can actually finish up the intersection. Excuse me. Okay, so the intersection the number of the sets that you are giving, that's the union of H and M, is going to be equal to 60. Why is it 60? It is 60 because the total number of students is 80, and the number that did not offer any of the two is 20. So if you do 80 minus 20, you will get 60. Therefore, the union of the two of them will contain 60 students, and that's equal to the number of M we said was 30, and the number of H is 40. So minus the intersection, which I called X. So if you use this approach, take this X to this side, you still get that X is 70 minus 60, which will still give you 10. Okay, so our intersection, which is intersection of M and H, will still be equal to 10. And finally you will now get what you're looking for, which is MC, that's complement of M. People that did not do M but are doing H, their intersection is what will give you actually this thing they're asking for. And of course, if you do that, you are going to get that is equal to n of h minus n of their intersection, which is exactly what I did earlier. N of h is 40 minus n of the intersection, which is 10. That's exactly what I did here, and that will give you what? Your 30 as the solution. Okay, so that is the solution for example or exercise 4 as was asked. And then next is to do exercise 5. All right, so let's move on to that. Okay, so question 5 here says that you are given, now 5 is coming from, meanwhile this question 4 is from set theory. Sorry, I didn't mention that. And even question 3 is also from set. Even question 2 is also from set. So only question 1 is from number system. Remember, the first topic this semester is number system, and the second is set theory. Okay, so the third or the fifth question now is coming from indices, which is the third topic. All right, so this is the question. It says we should find the value of, okay, let me put it this way. You are given that 9 is raised to the power of x minus 4 times 3 to the power of x plus 1, and then you now have plus 27 is equal to 0, and you are to find the value of x. That's what the question says. So what do? Excuse me. So, and here you are asked to, there is a little hint there, but with or without that hint, you should be able to do that. And the hint there is that you should let p be equal to 3 to the power of x. And of course, this is always seen when you have a particular indices question that will probably lead you to quadratic. So let's see. How are you going to see that? From here, you can, in fact, even from here, you can always already see 3 to the power of x. So, but here also, you should also be seeing 3 to the power of x. How? Okay, so let's go into it. So what are we going to do? 9 is the same thing as 3 to the power of 2. And there is already an existing power. And from the last exercises we did on this channel on indices, I said there that once a power is already existing and you're bringing up another power, both of them will multiply. So this is equal to 3 power 2x, then minus 4. Then let me use dots to write that multiplication. Then here, by the law of indices, if I have a to the power of x plus y is the same thing as a to the power of x multiplied by a to the power of y. So I can split this that way, and that will give me 3 to the power of x multiplied by 3 to the power of 1. Then I'll bring down the constant, which is 27, and that will be equal to 0. Okay, so pay attention to that. What's that going to give us? So here now, my eye is now peeled on where there is 3 to the power of x. Is there 3 to the power of x here? And the answer is yes. And how do you see that? You know, I can actually write that thing up here as 3 to the power of x all raised to the power of 2. If I open up this bracket again, these 2 will still multiply this x and give me back 2x. So I have not changed anything. But why did I do that? So that I can see clearly my 3 to the power of x. And then you now have 4 will multiply this 3, and that will give you 12. Then multiplying 3 to the power of x. So you leave that one that way. Plus 27 is equal to 0. And then immediately you can now substitute. Remember we said let it be p. So you now have p squared minus 12p plus 27 is equal to 0. Okay, so now you want to now solve this quadratic equation, and to do that you can try factorization. And can factorization go? You're looking for two numbers that will multiply to give you 27, and when they add you will get minus 12. Do we have such numbers? Okay, Of course, 3 and 9 can do it. Minus 3 and minus 9. Okay, so of course if you add these two, you get minus 12, and if you multiply them, you get 27. So both of them are perfect. And like I will always say, you can jump one step here, open your two brackets, so you just have p into bracket, then another p into this bracket equal to 0. So what do you fill there here with? You use the two numbers you have here to fill this place. So here will be minus 3 and here will be minus 9, and you are done. So immediately either, okay, so either that your p minus 3 is 0 or your p minus 9 is 0, and immediately your answer has come up. So your p alone is equal to 3 or equal to 9, and this is the value for p. So you have not yet gotten the value for x, and you need to get the value for x. So to get your x, you will now substitute p into this equation here. So you are going to do that for the two values of p. So we'll start for p equal to 3. So I'm going to have that my 3 is equal to 3 raised to power x. Remember, my p now is 3. So in this case here, I can now say this is 3 to the power 1 is equal to 3 to power x, and therefore my x here, since the bases are the same, so my x will be equal to 1. Alright, okay, you are following? Yeah, that's beautiful. Okay, so now here, right, so remember to like, remember to give a thumbs up to the video. You can just move away from the live chat and give a thumbs up to the video while it's going on, and you can as well give some emojis while we move on. Okay, so and then for the second one, you have that for p equal to 9. So my, what it means is that my 9 is equal to 3 to the power of x. And what is 9? You try to put it in base 3, which will give you 3 to the power of 2 is equal to 3 to the power of x. And therefore, our x alone is equal to 2. So what it means is that for that equation which they asked us to solve, our x is equal to 1 or 2. And that is what they asked us to get. So we have gotten the value for x as 1 or 2. Okay, so we will move on to the next question. Okay, on to the next question. There we are to get the value for, so okay, let's see if this place can still enter it, and that's number 6. Okay, number 6, let me see if I can share here into 2. Right, so for number 6 we are given 5 to the power of 2x minus 5 to the power of x plus 1. Then we now have plus 4 is equal to 0. Okay, so what do we do here? Here we are also looking for the value of x. Okay, so what are we going to do here? The same way you can also try to simplify this, and they actually gave that as a hint. Okay, so you can bring in, you can already see 5 to the power of x here. So that means I should put that in a bracket and raise it to the power of 2, just as I did up here. Okay, so that means this is going to be minus 5 to the power of x. If I follow that same rule of multiplication, this will now be times 5 to the power of 1. Then I'll bring down my plus 4. Everything is equal to 0. Okay, so this is going to be, so here now you can now also do the same substitution. Let our 5 to the power of x be given a name. We can call it p. Actually, that's what they gave as a hint. Call it p. So if you do that, so here is going to be p squared minus, this one now is p times 5, which is 5p, then plus 4 is equal to 0. And then you can try to now factorize again. So here you're looking for two numbers that will add to give you minus 5, and when they multiply they give you 4. And it's obvious, minus 4 and minus 1. And here again you will open your two brackets. This will give you p minus 4 and p minus 1, and that's equal to 0. Okay, so which means now that my p is equal to, of course, if you equate the two of them to 0, you get that p is equal to 1 or p is equal to 4. Okay, so but that's the value of p. So to now get our x, so you will now use these two values. So if you start from, okay, for the first one, when p is equal to 1, here again we can divide this into 2. So when p is equal to 1, so what it means is that our 5 to the power of x is equal to 1. And so to get our x, we can try to write 1 in base 5. And that's going to give us 5 to the power of 0. Therefore, our x alone is equal to 0 for this particular value of p. So we now go for the other value of p when p is equal to 4. Right? This is beautiful. So what do? The same way, 5 to the power of x will be equal to 4. Okay. Here we try to write 1 in base 5. Now the question is, can we write 4 in base 5? Alright, yeah. Okay, so can we write 4 in base 5? And of course it's not possible. Okay, so what do? It's not easily possible. So once it is not easily possible to do that, you take the log of both sides. So if we take the log, why are we taking log? Because logarithm has the capacity to bring down a power. So it can help us bring down this x. Okay, because that x is hanging there, forming J's bond. So we can bring it down, and if it comes down, you will now have x log 5 is equal to log 4. And immediately, you're welcome, Danny. Okay, so that is going to give us x alone is equal to log 4 all over log 5. And this is your solution. However, I want you to take note that, like I will always say, that the problem sometimes is not that you solved it correctly. The problem is it is possible to finish solving and your solution is not the form that the option is taking. So you will need to be able to write your solutions in different forms. So if I have log 4 over log 5, is there any other way we can write this? Yes. Number one, you can use your calculator to get the value and it will be in decimal. Okay, so that's one way, but that's not exactly what I want to show you here. Alright, so what is it that I want to show you? There's a rule in log which we all did that told us that if I have log x base m all over log y base m, that means two logarithms are dividing and their bases are the same, then I can actually pick log x, while the number of the logarithm here will now just be the base. So these two things are equal. Once the bases are the same, you can gather the two of them into one logarithm. We call it law of change of base. There are about two of them, that law of change of base. So this is one of it. So this is actually the same thing as now log 4 base 5. The question is how? Okay, so whenever you are given a log without a base, we call it the common logarithm. So the base here is 10 and the base here is also 10. So that means it satisfies this condition. The bases are the same, and so you pick your 4 as the number and the 5 as the base of the single log. So you can write this as log 4 over 5, or you can write it as log 4 to base 5. Alright, and you can also write it in decimal form like I said. Okay, and that is the solution for that particular number. So, alright, that's the solution for that. Okay, let me keep it this way so that you'll be seeing it. Alright, okay, so that is the solution for that. Okay, so now we move on to the next one. Right? So the next is question 7. We just finished with number 6. Okay, so number 7 is obviously very easy. Let me see if I will reach number 10 and we'll take a break if I'm able to do that. Okay, so let's see. Number 6 or 7, sorry, says that you're given 3a to the power of 4 multiplied by, here we have 10a to the power, everything to the power of 3, and then you are dividing by 5a squared all to the power of 3. I think I'm going to be leaving you to do this one by yourself. So just open up the bracket. This power will come on 10 and also come on a. The same thing will happen here. And then when you are multiplying, numbers will multiply numbers, alphabet will multiply alphabet. And when you are dividing, the same thing will happen. Okay, so I will allow you to take care of example or question 7. Okay, so we move over to question 8. So for 8, we are asked to express the log of, here you have 75 all over 16 minus 2 log, okay, 5 over 9, then plus the log of 32 over 243, okay, in terms of log 2. Wow. Okay, so we want to express this in terms of log 2. Okay, so I think I like this particular question. So what is expected of you here? Right? Simple. Just to try to explain, to simplify. Remember, like I said, we have now moved from indices to logarithm, okay, which is the 4th topic according to your course outline. Alright, so let's go. So now, whenever you're given a problem, like I will always say, always remember to start by what you know how to do and then move to other things. So from here, I will try to simplify this as much as possible by applying the rule of logarithm. Okay, so first of all, I will move this coefficient up. So this is going to give me the log of 75 over 16 minus, so these two will come up, and that will be the log of 5 over 9 all squared, then plus the log of, here you now have 32 all over 243. Beautiful. Okay, so what are you expected to do next? So the next thing is to evaluate this power here. So of course, you know power distributes, so it's going to come on the two numbers there. So and 5 squared is 25 and 9 squared is 81. So I'm going to remove this to write 25 over 81. Okay, permit me to do that so that we can move on. So the next now is to apply our rule of logarithm, which says that if you have log a plus log b, that addition changes to multiplication. So you just have only one log, then a will multiply b. And if it is subtraction, log a minus log b will change to division. So there you will have log of a all over b. Okay, yeah, all right, so you're welcome. Okay, so what's the next thing to do? So we are going to apply the two rules at once. So we'll first of all do the addition. So this is going to be 1 log now. Then let's bring a big bracket. So the ones that are adding will multiply. So I'll have 75 over 16. multiplied by 32. Okay, let me write it this way. Let's write it this way. 75 over 16. You can actually do this subtraction next. So which is divided by 25 over 81. And then this addition is multiplication, which is times 32 over 243. This is beautiful. I think I love that. So what's that going to give us? So we'll now try to apply our basic knowledge of fractions. So which says that I can change division into multiplication. Is that correct? Yes. So I will have 75 over 16. When the division changes to multiplication, something will happen to the next fraction, and that will give you 81 all over 25. It will invert, and then finally you have multiply by 32 over 243. Okay, so that is going to give us, here you will now have the log of so you now try to reduce terms if there is any one that can be reduced. So let's see. Of course, 16 can go into 32 to give us 2. 25 can go into 75 to give us 3. Okay, and 81 can go into 243 to give us 3. I want you to be checking all this. All right, and finally 3 can go into 3, and both of them will give us 1 1. So you can see everything there has actually cancelled out except 2. So your answer is equal to the log of 2, and that is the solution to this problem. Funny enough, they said we should express it in terms of log 2, and everything just gave us log 2. So but be careful, it may not always be so. Okay, so it can be maybe 3 times log 2 or 4 times log 2 or whatever. So but expressing in terms of log 2 means that everything should be simplified to contain only log 2. Okay, so and that is for number 8. Excuse me. So we move over to number 9. So number 9, we are asked to simplify another logarithm, the log of root of 27 plus the log of root of 8 all over the log of 3 plus the log of 2. So what is this going to do for us? We are going to have okay, so we'll try to simplify using the rule. Remember, we just said now that addition will change to multiplication. Okay, so what is that going to give us? So this is going to be the log of root 27 multiplied by root 8. Okay, so is that correct? Are you sure that is correct? Okay, beautiful. So, and that is all over. Here now will become the log of 3 times 2, which is 6. Okay, so now we are going to apply surd rule. And what is surd rule? Surd rule says that if 2 surds or 2 square roots multiply, both of the numbers can come under 1 root, and the 2 numbers will multiply. So what is 27 times 8? That is 54 times 4, which is 108 times 2. Okay, let me look at that. 27 times 8. Okay, yeah, 216. So there we have 216. But there is a way you can actually do this much easier. This is log 6. And that is to simplify what you have here. Assuming I simplified root 27 to 3 root 3. Of course, you know that this will give you 9 times 3, which is 3 root 3. And then I simplify root 8 into 2 root 2. Okay, so you discover that what if you now multiply these two, number outside will multiply number, and that will be root 6 root 6, which is exactly what we needed here. In fact, that's what we are going to have here, because 216 is the same thing as 36 times 6. Yes, so if you split it that way, you are going to get the log of root 36 times 6 all over the log of 6. So what am I actually looking for? I'm looking for a way to get maybe 6 somewhere, so that it will help me, log 6 somewhere up, so that it can allow me do some cancellations. So let's try that. So this is now going to become the log of the root of 36 is 6. So we have root so which will give us 6 root 6 here. Okay, is this going to help us achieve what we want? Instead of doing this way, let's go back to what we had originally. Remember that I'm trying to see how I can get the 6 raised to power something in my numerator. So there's no need actually splitting this that way. So I could have written this as 6 to the power of 3, which is 216. Yes, and that's okay. So what do I do with that now? So that's now going to give me, by rule of indices, I can write that as the log of 6 to the power of 3 over 2. Remember that square root means power half. So if that half multiplies 3, that will give you 3 over 2. And this is all over the log of 6. And immediately, I can now apply the rule that allows this to come to the back. And when it does, you now have 3 over 2 log 6 all over log 6. And then, of course, this will cancel this to just give you 3 all over 2 as your solution. Okay, so and that is the solution to this particular example 9. Meanwhile, if I had continued in that other approach, would I have gotten the same solution? Can we confirm? Yes, I think so. Okay, yeah, you can actually check that. Of course, that is going to give you log 6, and then okay, but that will take us a little more time to decipher, of course. Okay, so but this is a better way to go. So you have 3 over 2 as your solution. All right, like I said, I'm going to take a break after number 10. So let's look at number 10, and it seems I'm going to leave number 10 as an exercise. So it says solve for x if log 225, I think that should be 225, not 255. That's a typographical error. So this is 225 all over log 15 is equal to the log of x. You are asked to find the value of x. How do you do that? Just simplify 225 into 15 to the power of 2, and then let your 2 come to the back, and then log 15 will cancel log 15. So you just have 2 is equal to log x, and then you look for x. Should I do that? No, I will leave it. But if you have a question there, you can actually ask me, and then I will respond, maybe with another video. But for your sake, so that you'll be able to do something, I will stop here for this first section, then before we go to the next section. So if you have any question, you can always drop it in the chat, even when we come back. All right, so have a very nice day. We'll take a break. It's already midnight. Maybe we'll continue this night for those of you who are still awake, or you can join us to see the recorded video, because I would like to finish this particular recording as much as possible. All right, see you later on. Bye.